For that, the library I'm using here is nbclust. Then I'm setting seed so that my output is same every time. Now the function that I'm using is nbclust within the bracket name of the data frame. Then the distance will be calculated in the form of Euclidean. Then the minimum number of clusters that I need is 2, maximum is 6. Method should be k-means. So run this command, and you will see one more graph here which will show you the optimal number of clusters. So graph says, so it uses Hubert index is a graphical method to determine the number of clusters. In the plot of Hubert index, that is this one index, we seek a significant knee that corresponds to the significant increase of the value of measure, that is the significant peak in Hubert index second difference plot. These are the D index is a graphical method of determining the number of clusters. In the plot of D index, we seek a significant knee. So they are telling you about the graphs here. You can see the first one, it is in the form of elbow and knee. So in the form of elbow, the optimal number of clusters are 2 here, 3 here, either 3 or 4. And here also you can see the optimal is either 3 or 4. So let's go ahead, and you can see what happens is nbclust, they responds you in 30 indices, which if you just question mark it, you will be getting a great help. nbclust package provides you 30 indices for determining the number of clusters, and proposes to users the best clustering scheme from the different results obtained, varying the combination of number of clusters, distance measures, and clustering methods. So the 6 proposed 2 as the best number of clusters, 7 proposed 3, 6 proposed 4, and 3 proposed 6. So you can see 7 proposed 3 here. So majority, they say that best number of clusters should be 3. So this is how you can select the best number of clusters that you need using elbow method. Now if one of the important part you should take care of while creating clusters is that if your data, I'm using a different data set here, I'll be creating 2 marks and a project marks here. So this is my data frame, and yes, one of the very important point in clustering is the data you are providing, it should be in the form of data frame only, so that it can pick up the values easily. So I have created a data frame here. In this data frame, as you can see, 2 of the marks are in same scale, but project marks are of different scale. They are high out of 150 here. So in order to get them in same scale so that your clusters are created properly, you need to scale your variables. To scale the variables, the function used is scale within the bracket name of your data frame. Otherwise, what will happen? These marks will dominate your data set and will create a bad clusters and will give you a bad output. So you should scale it. So when you scale your data, let's see the data set. So this is how your data set looks like. It follows z-score scaling, wherein your data is lies between -3 to +3, and these are the average marks of each of the project, each of the variables. So marks 1, the average is 67 here. Marks 2, it is around 67.8, and project is 100. So this is how you have been scaled in the data set. Now, if you want to create a cluster means from it, you use k-means. I am taking 2 centers here, that means 2 clusters. Let's see here. So this is how my data set has been divided. You can say there are 2 clusters. For marks 1, these are the 2 averages, marks 2, these averages, and project are these 2 averages. And if I combine my clusters to my data set, so this is how it looks like. My first student, it has been allotted in cluster 1, same as in second one in cluster 1, and 3 and 4 in cluster 2. So the number you can see there are two clusters with 2 and 3 values.